Students, today's lesson is on surface area and volumes of similar solids. So we'll start with some vocabulary. Similar solids are solids that have the same shape and proportional corresponding dimensions. So same idea as similar two-dimensional shapes, but here we're talking about solids. So we want to figure out, first of all, which cylinder is similar to cylinder A. So we know that similar solids have proportional corresponding dimensions. So if we compare the height of cylinder A and B and the radii of cylinder A and B, we should see a proportional relationship if indeed those two solids are similar. So let's start with that, A and B. We'll test this one, and if that doesn't work, we'll try A and C. So if we want to compare the two heights, that's a ratio of 4 to 3. And if we want to compare the radii, we have a proportion of 6 to 5. So neither of those can be simplified. If we use cross products, we can see that 4 times 5 is 20 and 3 times 6 is 18. So not proportional here. So let's go ahead and try comparing cylinder A and C. So here if we compare the heights, we have a ratio of 4 to 5. And if we compare the radii, we have a proportion of 6 to 7.5. So here we could simplify both of these and have a common denominator of 15. So we could change this to 12 over 15 and see that that's equal to 12 over 15. Or we could use cross products. Either way, we have a product of 30. So yes, A and C are proportional. Let's go ahead and look at example 2, where we're finding missing measures in similar solids. So this time we're told that the cones are similar. We're going to find the missing dimension, which is the slant height of cone Y. So here we see we have the radius of both cones. They have a ratio of 5 to 7. We'll see if that's, or we know that that is proportional to the ratio of the slant heights, which is 13 over L. So now we just need to solve this proportion to find the slant height. So we're going to use cross products. That's 5 times L equals 13 times 7, which is 91. We'll divide both sides by 5, and we get that the slant height is 18.2 yards. Okay? A key idea here, we've been comparing linear measures, so radius, height, slant height, those are all one-dimensional measurements. They're usually represented by a lowercase letter. So these are all examples of linear measurements of a three-dimensional shape. Length, width, height, radius, radius, radius. All of those are linear measures. We're going to look at surface areas and volumes where we're not looking at linear measures. So here we have these two solids. We're told that they're similar. If we want to compare the ratio of their surface areas, that's not equal to the ratios of one of their linear measures. If we have some linear measures, like the radius of both of these, we need to compare the ratio of the surface areas to the square of the ratios of those linear measurements. That sort of makes sense because we know that surface area is a two-dimensional measurement, and the linear measurements are a one-dimensional measurement. On the other hand, if we're comparing volumes, because volume is a three-dimensional measurement, if we know that two solids are similar, the ratio of their volumes is equal to the cube of the ratio of one of those corresponding linear measurements. So if we have the height or the radius of both of the cylinders, we need to cube that ratio in order to compare that to the two volumes. So let's practice doing that. Here we have finding the surface area. So we're told that these pyramids are similar, and we're given the heights. One has a height of 6 and one has a height of 10. And we're given the surface area of just the larger of the two pyramids. So we need to solve for the surface area of the smaller pyramid. So we know that we're going to solve for S. So I'm going to write S over 600 is equal to, and then instead of comparing this to 6 over 10, I'm going to compare it to 6 over 10 squared. So I need to square this ratio in order to make it equivalent to the ratio of the surface areas. So I'm going to simplify this first to S over 600 equals 36 over 100. I'll square both the numerator and the denominator. And then I'm going to use cross products to simplify. So 100S equals, that's 21,600 is 600 times 36. I'll divide by 100, and I get the surface area equals 216 square feet. All right, now we're going to do the same thing with volume. Now we have the dimensions of the touch tank at an aquarium are doubled. What is the volume of the new touch tank? So here's the original tank. I don't even have the dimensions of it, but I do know that in the new touch tank, the dimensions are doubled. So whatever the length is, I'm going to double it. Whatever the width was, I'm going to double that. So that means that the original and the new tanks have a ratio of 1 to 2. Whatever those dimensions happen to be, they have a ratio of 1 to 2. And then I'm going to compare that to the volume of the original tank, which is 2,000, and the volume of the new tank. But I can't just use this 1/2. Because volume is a 3-dimensional measurement, I need to cube this ratio. So as I simplify that, that'll be 1 over 8 equals 2,000 over V. And then I can use cross products to simplify that. That's V equals 16,000, and that will be in cubic feet. All right, that's it. Go ahead and try a few on your own. I'll see you soon.